In this video, we want to see how many nth order partial derivatives does a function with two variables have, and if these partial derivatives are all continuous, how many distinct nth order partial derivative does the function have. Let's focus on the first part. How many nth order partial derivative does a function of two variables have? Suppose we have a function z with two variables x and y. For the first order partial derivative, we have two choices. We can find partial derivative with respect to x or partial derivative with respect to y. So for the first order partial derivative, we have two partial derivatives. The partial derivative with respect to x, partial derivative with respect to y. Now let's see for second order partial derivative how many answers we have. From fx, the partial derivative with respect to x, we can take derivative with respect to x again, or we can take derivative with respect to y this time. From fy, we can take derivative with respect to x, or we can take derivative with respect to y. How many second order partial derivative we have? 4. Now let's see for the third order partial derivative how many different answers we have. From fxx, we have two choices again, fxxx or fxxy. From fxy, we can take derivative with respect to either x or with respect to y again. From this we have two choices, from this also we have two choices. So one answer here, one answer here, one answer here, one answer. So for the third order partial derivatives, we have 8 partial derivatives. So based on this pattern, can you guess that how many nth order partial derivative does a function with two variables have? First order, 2. So for the first order, 2 to the 1. For the second order, 2 to the 2. For the third order derivatives, we have 2 to the 3 partial derivatives. So if we continue this pattern for each order that we go to the next order, we have times 2. This pattern continues. So for the nth order, we have 2 to the n partial derivatives. Now, suppose the partial derivatives are continuous. Now, how many distinct nth order partial derivative does the function have? Because we know that some of these partial derivatives, when the partial derivatives are continuous, are equal to each other. And the answer of them is equal, based on the Killer-Rose theorem. How many distinct nth order partial derivative we have? For the first order, attention, for the first order, these are of course different. So we have two distinct. For the second order, this is the same as this. The order of differentiation doesn't matter. So we have 1, 2, because these two are the same. 3 different partial derivatives we have. For the third order, we have this. Attention, fxxy, fxyx, and yes, fyxx, which we have to have here. These are the same. If you check this by yourself, you will see that 4 different answers we have. And if we continue this, always you will see that for each order, 1 more partial derivative we have. So for the nth order, how many distinct partial derivative does the function have? For the nth order, we have n plus 1 distinct partial derivative.